So let's look at exercise 2.3. The first question is, which of the following is a relational function? They've given 2, 1, 5, 1, 8, 1, 11, 1, 14, 1, 17, 1. The first element of the ordered pair is occurring only once. Therefore, this relation is definitely a function. So let's go to next sum. Second subdivision, the first sum is 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6 and 14, 7. So let's see, 2, 4, 6, 8, 10, 12, 14. Yeah, so it's also a function because the first element is occurring only once. So let's go to third sum. Is a 1, 3, a 1, 5, a 2, 5. It's definitely not a function. It's only a relation because first element of the ordered pair 1 is occurring twice. So then that's about the first sum. Let's go to second question. Is f of x is equal to minus mod x. This was already there in the previous video. X is an element of all real number. And for y, the mod function will range from 0 to infinity with the negative outside makes it minus infinity till 0 inclusive. You cannot include the infinity anyway. This is the range y is an element of. So third, there's another subdivision here, which is f of x is equal to root of 9 minus x square. It's in the numerator. Therefore, x square has to be lesser than or equal to 9, x has to be lesser than or equal to plus 3, or x has to be greater than or equal to minus 3. Put it on the number line, a minus 3 and a plus 3. X is greater than or equal to minus 3. Fill it and then do it. X is lesser than or equal to plus 3. Fill it and take it. The intersection part is minus 3 to plus 3. Close bracket. This is x is an element of. And they ask you for y. It's simple. It's only numerator. So you can imagine like this. This can be 3 where it will become 9 and the answer can be 0. This can become a 0, the answer can be 3, and y has to be always remaining positive 0 to 3, close bracket. Because as per definition, the square root functions, the y value, the range has to be always positive. So let's go to third question. Third question is, they have given f of x is equal to 2x minus 5. Write down the value of f of 0. It's 2 into 0 minus 5, which is minus 5. Then similarly, f of 7 and f of minus 3, you can do it on your own. Let's go to fourth question. The fourth question is, they've given temperature in Celsius is 9C by 5 plus 32. Okay, what is it? I think the Fahrenheit. This is Fahrenheit. I think this is Fahrenheit is equal to 9C by 5, where C is the Celsius. You have to write. They're asking you temperature at 0 T. Okay, this they've given Fahrenheit as some T of C, which is basically Fahrenheit. T of C, when T of 0 means in the place of C you'll substitute 0. So T of 0 itself is just 32. Then they ask me T of 28. So in the place of C, you can substitute 28, 9 into 28 by 5 plus 32. Like this, you can go on with your answers. Now, next, there is a fourth subdivision in this. They ask you, what is C? You can consider this as F. Fahrenheit is equal to 9C by 5 plus 32. Take it, that's it. F minus 32 is equal to 9C by 5. 5 can be multiplied with it. 9C, so this can be brought down. So you got a Celsius in terms of Fahrenheit. Okay, so this is what is it? They're asking, find the value of C. Yeah, I found the value of C, where I've written F, where F itself is nothing but T of C. Okay, so that's about the sum. Let's go to fifth question. The fifth question is, they've given f of x is equal to 2 minus 3x. They've already given the domain, real number, and they've given a real number greater than 0 also. So what will be my range? You start thinking, you put it as 0. You are not supposed to put as 0, it has to be greater than 0. Assume it as 0, the minimum value will be 2. Minimum or maximum will be 2. Because it can be greater than 0 means this can go up to infinity. And 2 minus infinity will be minus infinity. But here 0 also cannot come. So open bracket 0. minus infinity till open bracket 0 is y. Y is an element of. I hope you understood, because x cannot be 0, but I am taking x as 0. So if it can take 2, it can't take 2. It has to be lesser than 2. That's what it means. Okay, sixth, there is another subdivision in this. The second subdivision, where f of x is equal to x square plus 2. The square numbers can take a value. X is an element of R. So square numbers can take a value 0 to infinity. In this sum, it was difficult because they have given x to be greater than 0. So you substitute 0 and get your value as 2. And then you go up to infinity, you get minus infinity. But it has to be really 2 to infinity, but you can't include the 2 because you can't include a 0 also. So open bracket 2 to infinity. X is an element of open bracket 2 to infinity. And in the sum, this square numbers 0 to infinity, put a plus 2 to it. It can be 2 to infinity. So it can be square bracket 2 to infinity will be my range. Infinity cannot be included. Square bracket only for a 2. That's my range. Okay, so that completes that exercise. Example 18. Example 18. In miscellaneous examples, let R be the set of real number where f of R is tending to R, which means domain is also real number, the codomain is also real number, where f of x is equal to x plus 10 is a linear function. Y is equal to x plus 10 is obviously a linear function. Sketch the graph. How do you sketch graph? You know how to do it. You put x as 0, x value and y value. X as 0, y is 10. X as minus 1, y is 9. X as plus 1, y is 11. And 2 points is enough to draw a graph. This is more than enough. So when you plot a graph, there is a 0, 10. And y, if x is, if y is 0, x is minus 10. So minus 10, 0. So this will be the line. You can just assume like this instead of doing this. Put x as 0, y is 10. Put y as 0, x is minus 10. 2 points is more than enough. At 10, 0, minus 10, 0, thus you drew the graph. That's all. So then that's about sketch the graph of a function. Done. It's a linear function. So let's go to next question. In this graph also, they are asking for what is the x-intercept is minus 10, 0. What is the y-intercept is where it's cutting x-axis. Y-axis is 10, 0. So that's enough. And so let's go to next question. It's the 19th question. Let R be a relation from Q to Q, which is given by R is equal to A, B. Ordered pair is A and B, which means this x and y, where A, B belongs to Q. And A minus B is an element of integer. Show that A, is an element of R for all Q, for all A is an element of Q. All that you take this x and y value, this A and B, subtract it, it should be integer. Then A minus A will be 0, which is also an integer. Therefore, it's true. Next, that's part number 1. Part number 2, A, B is an element of R. Then does it imply that B, A is an element of R? A minus B is an integer. Let's take it as lambda, some value. B minus A will be minus lambda. If this is an integer, this is also an integer only. Therefore, true. So let's go to third one, which is A, B is an element of R. And B, C is an element of R has been given, which means A minus B is equal to lambda, B minus C is equal to mu. Assume some constant lambda and mu. Does it imply A, C is an element of relation? Do A minus C, is it an integer? You want A minus C, add this equation 1 and this equation 2. The B and B get cancelled. A minus C will be lambda plus mu. If this is an integer, this is an integer. Addition of 2 integer will also be an integer. So A minus C will be an element of integer, and therefore this is also satisfying the relation. This relationship is about when you subtract, you should get integer. You subtract an A minus B, you get an integer. You subtract an A minus A, 0 is an integer. A minus B is integer. B minus A will be negative integer. That's all. So like this. Okay. So let's go to next question. Is the 20th question, where they've given a function which is 1, 1, a 2, 3, 0 comma minus 1, minus 1 comma minus 3. This is a linear function, it seems. They are saying that this is a linear function. How do you know it's a linear function? What function will it be? If it's 1, it's 1. If it's 2, it's 1 more. So how can we find the function? Every linear function is f of x is equal to ax plus b. By heart this. F of x is equal to ax plus b. Any linear function. Which is nothing but y is equal to ax plus b. You know x value is this, y value is this, x value is this, y value. All these are x and y values. You substitute this x value and y value. Y ku badala 1, a ku badala, x ku badala 1. You get a plus b to be 1. And you can take this one and substitute here. It's convenient. 0. X is 0. So y will be b. Y itself is minus 1. So b itself is minus 1. You know b is minus 1. Therefore what will be a? A will be 2. Take it and put it in this. Y is equal to ax plus b. Y is equal to ax plus b. So thus you got your linear equation. You should always memorize this. F of x is equal to ax plus b is a linear function. You know x values and y values from these, and you can substitute, get linear equation, solve it. Okay, so let's go to next question. You have to find the domain of this x square plus 3x plus 5 by x square minus 5x plus 4. So luckily they've asked me only domain, they didn't ask me for range. I am escaping from a big problem. So then factorize this denominator. X square minus 5x plus 4 is x square minus 2 2s are 4. How will I get 4 1s are 4? So x square minus 4x minus 1x plus 4, which is x into x minus 4 minus 1 into x minus 4, which is x minus 1 into x minus 4. Cut this and write it as x minus 1 into x minus 4. You know denominator cannot be equal to 0, so x cannot be 1 and x cannot be 4. So x can take all real number other than 1 comma 4. That's how you define your domain. Luckily they didn't ask me for a range, so no problem. So let's go to the next sum, which is a 22nd sum. They have given f of x to be a 1 minus x in x is less than 0 and 1 when x is equal to 0 and x plus 1 when x is greater than 0. This shows that when it's less than 1 it is negative, greater than 1 it's positive, which means it's a mod function. You plot this graph now and see, right? X is 0. When x is equal to 0, in this you get y is equal to 1. When x is equal to x is equal to 1, y will become 0. Just take this function alone. Y is equal to 1 minus x. So join this, you get a graph like this. Take this and write when y is equal to x plus 1 and x is equal to 0, y is equal to 1. X is equal to 1, y is equal to 2. X is equal to 0, y is equal to 1. X is equal to 0, y is equal to 1. Okay, 1 second. Let's plot this graph. First graph, y is equal to 1 minus x. When x is 0, y is 1. Y is 0, x is 1. Correct? So 0 comma 1, y is 0, x is 0, y is 1, y is 0, x is 1. The graph is like this. Let's do this graph. When x is 0, y is 1, y is 0, x is minus 1. So 0 comma 1 and minus 1 comma 0. So this is like this and this is like this. So this is basically a mod function. Actually this, to be more precise, as soon as I see this, I know when x is less than 0, it's going to be like this. When x is greater than 0, it's going to be like this. When x is 1, y is 2. When x is 0, y is 1. In this, so this is this graph, which is mod of x. Mod of x minus x plus 1. This is, the cutting point is at 1. Let me explore this sum again. So this function will be, this itself is mod x. It's gone up by 1. So it's mod x plus 1. Can I keep it like this? It's mod x plus 1 because this mod x, when x is less than 0, become minus x. When x is greater than 0, becomes plus x. So add a plus 1 to this, add a plus 1 to this. Can you see? This is this and this is this. So you should understand that this is how this graph is and this is the way to plot. Just give values for it, but it should be like this. You should understand that this is nothing but, since there is a minus x and since there is a plus x and this x is less than 0, greater than 0, you understand this mod x plus 1 is the function. You have to redefine like that. Drawing the points is not working out here much for me. I would rather identify this as a mod function straight away. So let's go to next question. Our next question is the exercise where they've given f of x is equal to x square when x is lying between 0 and 3 and 3x when x is lying between 3 and 10. So then you have to write this f in ordered pair. When x is 0, y is 0. When x is 1, y is 1, including this function, first function. X is 2, y is 4. X is 3, y is 9. I'm done with this because it lies between 0 and 3. I've given values 0, 1, 2, 3. Now coming back to here, 3 to 10. So when I put 3, 3 3s are 9. Okay, it's the same as this, so I can ignore this. When I put 4, it's 4 3s are 12. When I put 5, 5 3s are 15. So like that it goes on till 10 and 30. So then therefore f is a function. It's not only a relation, it's also a function because the first element, though it occurred again, it was mapped only to 9, so we can ignore it, and first element is occurring only once. So let's go to next function, which is g of x is equal to x square where x is lying between 0 and 2, and also 3x when x is lying between 2 and 10. So writing this g as an ordered pair, x is 0, y is 0, x is 1, y is 1, x is 2, y is 4, considering this function. And now going back here, n x is 2, y is 6 in this function. And 2 is getting mapped to 4, 2 is getting mapped to 6. Stop it. Don't write any further. This shows that it's not a function. It's only a relation, not a function, because first element is occurring twice. So let's go to second question. Is f of x is equal to x square has been given. Find f of 1.1 minus f of 1 by 1.1 minus 1. F of 1.1 is 1.1 the whole square. F of 1 is just 1 square. Putting it here, 1.1 the whole square minus 1 by 1.1 minus 1. Don't sit and multiply, write it as a plus b into a minus b on the numerator. And a minus b is there, this and this get cancelled. You'll be left with 1.1 plus 1, which will be 2.1. That's all. So let's go to third question. F of x is equal to x square plus 2x plus 1 by x square minus 8x plus 12. Find the domain. Obviously, they wouldn't ask the range for such complex question. Just factorize it. X squared, only the denominator, take it and factorize. 6 2s are 12. X square minus 6x minus 2x plus 12. 1 second, hold on. Okay, so then x square, x into x minus 6 minus 2 into x minus 6, which is x minus 2 into x minus 6. Strike it off and write x minus 2 into x minus 6. You know denominator, x cannot be 2, x cannot be 6. Therefore, the x is an element of all real number other than 2 and 6. Write it in floral bracket. Let's go to the next question, which is the fourth question. Find the domain and the range of f of x is equal to root of x minus 1. It's only numerator. It can become 0, but x has to be greater than 1 because root negative should not come. So x has to be greater than 1, that's all. So it cannot be 1, it cannot be 1, it can be equal to 1. So close bracket 1 to infinity is x is an element of. What about range? If they ask you y is equal to root of x minus 1, you know it can get the value 1 till about infinity. So if square root of 0 will be 0 and square root of a larger number will be infinity. So the y will also be from 0 to infinity. Okay, so but I can't anyway include negative numbers. No, square root functions has to be always positive for the range. So fifth question, f of x is equal to mod of x minus 1. X can take an element of all real number, and mod functions will always be positive, right? So it can be from 0 to infinity. Y is an element of 0 inclusive till infinity open bracket. So let's go to sixth sum. Sixth sum is they've given f is equal to x comma x square plus 1 plus x square. Very, very important sum, where x is an element of R. Determine the range. Okay, this means this is x and this is y. To determine range, y is x square by 1 plus x square. You should take it and write it like this, or you should write f of x is equal to x square by 1 plus x square and then convert it like this. Now we have to find the range. If you have to find the range in this, as soon as you see, range will only be positive values, and it can start from 0 onwards, because x can be 0 also, no? So even negative numbers can be x, but however in this we will get only positive. So y will always be an element of 0 inclusive till infinity. Is this correct? Would it be correct? Yes, because x square by 1 plus x square. Let's cross multiply and see. Okay, y plus yx square is equal to x square. Y is equal to x square minus yx square. X square common, 1 minus y is equal to y. X square is equal to y by 1 minus y. X is equal to root of y by 1 minus y. Y cannot be 1. What did I write here? This is wrong then. So y cannot be 1. Why? Because the denominator is always 1 greater than the numerator. So it will only be a decimal number. The answers for this will be less than 1. That inference you should know, and look at this, root kulla negative varakudadu. So therefore y has to be lesser than 1 and y cannot be 1. So therefore you understand that it is going to be always a decimal number. There is another condition here where the numerator y also can be negative and the denominator of 1 minus y also can be negative. It's negative is possible, but both has to be negative, which means the second condition is this y has to be lesser than or equal to 0 in the denominator. The denominator of y also can be negative, which means y can also be greater than or equal to 1. Greater than equal to, no, greater than 1, because this is denominator, this is numerator. Greater than only, no equal to. So put a 0 is lesser than or equal to 0. Y has to be greater than or equal to 1. For both being negative. Such a condition is not coming because there is no intersection at all here. So then leave it, just come back here. You know that the denominator is 1 more than the numerator. Finish the sum, don't do all this. 1 more than the numerator. Therefore only decimal numbers are possible. Can it be 0? Yes, it can be 0 because x can be 0. Till 1 open bracket is what is y an element of. This is all unnecessary and you will not get an answer in this method in this sum. You should observe that the denominator is 1 greater than numerator in that sum. So let's go to 7th question. F of x is equal to x plus 1. G of x is equal to 2x minus 3. They are asking f plus g of x. Just add it, 3x minus 2. So f minus g of x, subtract it, minus x plus 4. F into g of x, multiply. When you multiply, it will be x plus 1 into 2x minus 3, multiply and write the answer. F by g of x will be f of x by g of x. You should write all that, okay? X plus 1 by 2x minus 3, but x cannot be equal to 3 by 2 because denominator cannot be 0. If you don't write that, they will not give you even single mark. So let's go to 8th question. Function f is equal to a 1 comma 1, a 2 comma 3, a 0 comma minus 1 and a minus 1 comma minus 3. They have already given that the linear function is ax plus b. Find a and b. This is your x value, this is your y value. y is equal to ax plus b, substituting 1 is equal to a plus b, equation number 1. Take this and substitute next because it's easy. Y is minus 1, a is 0, so b is equal to minus 1, so a is equal to plus 2. On finding this, substitute it back here, y is equal to 2x minus 1. It's the same question as the example. There, they didn't even give you this, they just said linear function. Linear function means you should memorize y is equal to ax plus b. So, 9th question. This is a question where the relation R is equal to a comma b, where a comma b is an element of natural number and they've given a is equal to b square. They're asking if a comma a will be a part of the relation. You know what? Natural number 1 is equal to 1 square, but 2 is not equal to 2 square. If you're going to assume these two numbers are the same, it's because they've given a comma a is not equal to a square for every a. For example, when a is equal to 1, this will apply. True only for a is equal to 1. A is greater than 1, it's not true. 2 is not equal to 2 square. Therefore, it's false. In the place of b, we are not able to put a. Okay, next, that's the first question. And second question is, a comma b is an element of the relation because a is equal to b square. Is b comma a an element of R? If a is equal to b square, will b be equal to a square? Never. If 4 is equal to 2 square, will 2 be equal to 4 square? Never. Therefore, this is also false statement. It cannot be b comma a is not an element of relation because the relation is determined by a is equal to b square. B will not be equal to a square because b will be equal to root of a, not a square. B is equal to root of a, not a square. So since okay, so third one, a comma b is an element of R has been given because a is equal to b square. B comma c is an element of R has been given because b is equal to c square. Is a comma c an element of R? Is a is equal to c square? Just see from this, what do you know? You know b is equal to root a. Substitute it here. Root a is equal to c square. Square it. C to the power 4. So therefore it's false. Justify it like this. Okay, so let's go to 10th question. The question is this, they have given a to be 1, 2, 3, 4. They've given b to be 1, 5, 9, 11, 15, 16. They've given the function to be 1, 5, 2, 9, 3, 1, 4, 5, 2, 1. They've given this function. F is a relation. Is this a relation? So can you see 1 is mapped to 5. 2 is getting mapped to 9. 3 is getting mapped to 1. 4 is getting mapped to 5. That's okay. First element of the ordered pair, is it occurring only once? No. In this it's occurring twice. But yeah, 2 is also getting mapped to again 1. So if you do like this, 1 is getting mapped to 5, 2 is getting mapped to 9, 2 is also getting mapped to 1. How is it possible? It's definitely not a function. It's only a relation from A to B. Okay, so let's go to next question. It's the 11th question. The 11th question is, let f be a function, f be a subset of integer cross integer, where f is equal to a comma a into b, comma a plus b, where a comma b is an element of z. Is f a function from z to z? So there's this question where this a comma b and a plus b, okay, where a b is an element of z. They're asking, is this a function from integer to integer? Okay, so then for example, if a is equal to 2 and b is equal to 3, so it's 23. And an a plus b will be actually a plus b will be 5. So it's not 23, 3 2 is 6 and this is 5. Okay, so then if you take 2 and 3, okay, if you take 2 and 3 to be an example, this is getting multiplied as 6, is getting added as 5. So you get a 6 comma 5. Now let's take the second case. Let's analyze with the second case. If a itself is 6, if a itself is 6, To satisfy this, b will be 1. Correct? 6 into 1 is 6. But this will be 6 plus 1, it will be 7. You are not getting the same answer, right? Here it is 7 and there it is. So meaning it's not a function. Or in other words, if you take a 6 and here also you take a 6, they both are getting, one is getting mapped to 5, another is getting mapped to 7. In this, how did you get the 6? By means of 2 and 3 getting multiplied. 2 and 3 getting multiplied. Where 2 plus 3 is getting you a 5. Or in this, it is 6 into 1 is getting multiplied. But 6 plus 1 is getting you 7. So whenever you are, the 6 is the domain here. The 6 is the domain here, which was a result of an A cross B, a Z cross Z, which is 2 and 3 and a 6 and 1. It's getting mapped to the different numbers, so it's definitely not a function. Okay, it's only a relation. So let's go to 12th question, where A is equal to 9, 10, 11, 12, 13, where the function, where A is turning to natural number, f of n is equal to highest prime factor of n. F of n is the highest prime factor of n, where A is turning to n, where f of n, the y value should be highest prime factor of n. What is the highest prime factor for 9? The highest prime factor for prime factor. So you have to write 3. Because it's not just highest factor. If it's highest factor, I would write 9. And then for 10, what is the highest prime factor? 5. What is the highest prime factor for 11? 11. Highest prime factor for 12 is 3. Because 6 2s are 12, 4 3s are 12, so then 3 is the highest prime factor. So let's go to next. What is the highest prime factor of 13? Is 13. Already you wrote a 3, so you can cancel this off. 3, 5, 11, 13 are the range of this question. I hope you understood, and I'm done with all this. Okay.